Hi, welcome to my Zoo Burst, done by Naisha Cox for my final project of Geology 1000. The name of my Zoo Burst is Dating the Earth, Rock and Fossil Edition. I chose this topic as my topic for my project because I find it quite interesting how geologists date the earth using rocks, fossils, minerals, and soils, and all the other things that they use to come up with a date of how old the earth is. This picture of the earth is a geological timescale of the earth, and the colors represent the different times and the different eras on the geological timescale of the earth. Basically saying that these certain areas are from different eras on the earth. Let's start off with James Hutton. He was a naturalist, and he came up with this quote: "We find no vestige of a beginning, no prospect of an end." Basically, it comes from, you know, the more information you know about the earth, there are endless possibilities of what could have happened and what we can find out. Okay, let's start with that book. So the age of the Earth is approximately 4.5 to 4.6 billion years old. There are many ways that scientists and geologists have came up with this theory, and it's a quite proven fact now that the Earth is this old. And I think it's amazing how they came about. Okay, so rocks and fossils provide us with two different things. We can either get a relative age, and then we'll use that to get us an absolute age. A relative age is just, it's close. It just lets you know that younger rocks are found on the bottom of younger rocks are found on top of older rocks. And it also lets you know that what it lets you know about the fossils that are inside of rocks. Absolute age, however, gives you an actual age of the rocks in years. It's like us with our birth date. I'm going to go to the pictures here. This is a fossil inside of a rock. Basically, scientists use rocks with fossils inside of them to relate them to a geologic time period. Okay, you know that there are different eras in the geologic time scale. You use the fossils to relate them to something that's that's in the geological time scale. Looking at this rock, we see many fossils. This tells us a lot about where this rock or where these fossils come from. Scientists use fossils to correlate them from one area to the next, which provides a relative worldwide order of rock formation, as well as divide the rock record into the geologic time periods and eras. We're going to look at a geological time scale here in a second. But real quick, I want to show you a video that helps describe why I chose this as my project.
So what does the fossil record now tell us? We have a general idea about how ages have been estimated in the rocks, but what do we see in the fossil record? Because that's another way to measure age. Well, first of all, there's something very strange here. A classical hit of propaganda. There's more than hits the eye in the geologic timetable. Let me put it out there again for you. It's a simplified one. Once again, we live in a visual civilization, so what you see sticks in there, right? Well, let's have a look in the first column there. That distance represents, as you can see, 600 million years, right? Let's move to the next column now. The same visual distance, it's only 100 million years. Let's move to the last one here. Exactly the same visual distance, it's only 10 million years now. You see there's this cute thing in there? They're trying to hide something. Something quite stunning. It's what I call the strange correlation between time and evolution. Let us assume the 4.7 billion year age of the Earth according to evolutionists. So for the first billion years, which is 25% of it, the Earth was lifeless. Fine, it needed to cool and all that. But then here comes a strange thing. For nearly 9 billion years, which is 62%, the planet is inhabited only by single-celled creatures. Then multiple-celled creatures, metazoans, cover only 13%, which is 625 million years. And guess what? The most evolved and complex of them all, us humans, only needed 0.002%. Now, according to Darwinian evolution, the simpler the creature, the faster it evolves, for two reasons. First of all, that every single mutation is important, because the creature is very simple. Number two, simple creatures have many generations in a short time, so the mutations are passed on to the next generation quickly. So you have all the ingredients for fast evolution. How come that most of the time there's no evolution? Those things are still those things. Single-cell creatures are single-cell creatures. And suddenly everything explodes.
Getting back to the book here, I just felt that that was important for the fact that there are so many questions. Geologists have so many questions about what happened with the Earth, and you know, the more information we know, the better off we are. So he showed you the geologic time scale. This is a more simplified version. Okay, we know the two different ways of dating rocks and fossils. We have relative dating and radioactive dating. Relative dating basically provides you with relationships and a sequence, which came first, second. Radioactive data uses radioactive decay to estimate age. With both, you can get a better understanding of the history of the Earth. Five fundamental geologic events that occur are deposition, erosion, intrusion, faulting, deformation, and uplift. Here I have a diagram that shows you what happened. This is showing you weathering, transportation, deposition, and setting. Basically, it's a cycle that happened, and that this diagram better breaks that down. This diagram here at the back shows erosion and deposition, but I can't pop it up. Okay, the 7 principles used in relative dating are the principles of superposition, the principle of original horizontality, the principle of original lateral continuity, the principle of cross-cutting relationships, the principle of intrusion, the principle of unconformities, the principle of false succession. Okay, so basically these strategic principles are rules that provide the foundation for relative dating. They help break down the complex sections of the Earth crust. They're just principles that tell you what happened in relative dating. It's a part of relative dating. And this picture here is an example of cross-cutting, as you can see here. Radioactive data, however, is different. It uses a parent and a daughter. And the parent element is basically the amount of radioactive element that passes through the parent element and the daughter element. That's how you determine the age of rocks and fossils, using those two things. So the larger number of the daughter elements are the older rocks, and the younger rocks are the ones that present smaller number of parent elements. So dating the Earth isn't always as easy as we think it is. There are many questions that geologists must ask to determine accurate date of rocks, such as the questions listed below. There are also some observations that are also needed and where they derive from, which are the age of the primordial crust, the age of moon rocks, the age of meteorites, the abundance of lead isotopes, the consistencies of these separate lines of evidence. So basically, you need a lot of evidence to prove your data. You need a lot of evidence to prove your findings. It's not as simple as just using two tests. There's a lot that geologists must derive from. And here I want to state how questions, the more you know, the more questions you ask, the more or the better the information that you come up with, it just provides you a more accurate or better information about dating of the earth. Geologists have to assume so much. They have to assume that the mineral being dated has remained a closed system throughout its life. That's a lot. Like, you have to prove that this has remained consistent throughout its whole lifespan, which is estimated at 4 billion years old. These are just examples of fossils and examples of how just dating rocks and other information. This is a clip, an embedded clip of something I found on YouTube that's quite interesting. Should copy and paste it and watch it sometime. Okay, so here's my works cited page. I found the book most interesting about finding information about dating rocks and dating the earth in the geologic time. Like I said, it's so amazing how you can just look at a rock and come up with just a relative age. Oh, this rock belongs in this era, or this fossil is associated with that era. So that's basically what my project breaks down. I didn't go too much in depth the geologic time scale because my project wasn't about the geologic time scale. It's more about just how do you test rocks, not where they belong, but how do you test them and how do you test fossils. And the other three are some helpful topics some helpful findings that I run across on the internet, and they helped a lot with my project. I hope you enjoy and have a good rest of your day. Thank you for watching. Bye bye.